Hello guys, and welcome back to my video. So in this video we'll be talking about convolutional neural networks. So convolutional neural networks are a type of neural networks that are used for image detection, right? Image classification and also object detection, right? So what happens is that images are highly dimensional matrices, right? So it's difficult for them, if we feed them into a regular neural network, it will explode, as these images have so many parameters, right? So a special architecture block which for the convolutional neural network. So the convolutional neural network, we have what you call the convolutional layer. So in the convolutional layer, we have the input, which is our image. We have the convolution, and also there's also the activation, which is the ReLU. And we also followed by we have pooling, and then we'll go on, we add another convolutional layer, and then we then flatten our matrices, and then we connect them to the fully connected layer, and then we pass them over to the softmax. So the softmax, after we pass them over the softmax, it displays probabilities of our classification, right? So this whole block is called the feature learning. So what is feature learning? So what happens with convolutional neural networks is that the first layers of the convolutional neural network, they take special features, right? Small features like edges, corners, right? So that's how the first layers of a convolutional neural network. Let's say, for example, if we have an image of a bicycle, the the first layers will be detecting wheels, circles, right? And then the shape of the pedal. The next layer will be detecting, let's say, half of the bicycle, and then the higher layers will be detecting the bicycle as it is, right? So in the convolutional block, we have what you call the convolutional layer. So the convolutional layer is the building block of any convolutional neural network, right? It is where most of the computation occurs. So inside there are components. We have the input data, which is our image. We have a filter, and we also have a feature map, right? And then let's assume that the image that we are inputting in our convolutional neural network, right, is a color image, which is made up of a matrix in 3D, right? This means that the input, we have 3 dimensions. That is a height, a width, and a depth, right? Which corresponds to the RGB in an image. So we also have a feature detector, also known as a kernel or a filter, which will move across the receptive fields of the image, taking it a feature expression, right? So this is the filter of a convolutional neural network, and then this is the input image. So what this filter does is that it moves across the receptor of the input image. So if it moves here, we then calculate the dot product of the input image and our filter, right? So we say 9 times 0 plus 4 times 2 plus 1 times 1 plus 1 times 4 plus 1 times 1 plus 1 times 0 plus 1 times 1 plus 2 times 0 plus 1 times 1, and then we get 16. So this is the dot product of this is the dot product of the input image and the input filter, right? So let's take a look at it using Excel, right? So let's take a look at it using Excel. So in this case, we have this input matrix. Let's say this is our input image. We have our filter. So our filter is a 3x3 matrix, and then we then get a 3x3 output matrix here. So what we do is that our filter starts with this section, right? It starts with this section. We then compute the dot product of this section by our filter here, and then we input the value here. So if I click here, you'll see that we'll compute the dot product of A1. This is A1 times H2 plus B1 times I2 plus C1 times J2. We compute this until we get what? We get 16. And then what happens next is that we then move our filter by 1 pixel, right? We then move our filter by 1 pixel. So we're here, we move it by 1 pixel. So this is determined by a parameter called the stride. So the stride is the number of pixels by which our filter should move, right? If we move 1 by 1 pixel, we then compute the dot product of this input field by our input, by our filter, our input image by our filter here, and then we get 11 here, as you can see, this sector, and then we get what? We get 11. We then move again 1 pixel to the right here. If we move, we then move 1 pixel. We compute this input image by our filter. We get 17 here, as you can check here. The spreadsheet is also showing us this sector, right? So after that, right? Right. So after that, we then move, let's say here, we're at the top here. We then move 1 pixel downwards here. If we move 1 pixel downwards here, we then compute it by our input, by our filter, we get 10. We move 1 pixel, we then move 1 pixel to the right, right? If we move again 1 pixel to the right, we compute it by our filter, we get 13. And then we then move 1 pixel again to the right, and then we compute it by our input filter, we get 22. We then move 1 pixel down again, we get 25, 12, and it goes on, right? So that's how the convolutional, that's how the filter, right? That's how the convolution works. This is the convolution part, right? So as we have talked about the feature, this feature is a two-dimensional metric array of weights, which represents part of the image. Well, most of them, they vary in size, but the typical size of the filter is a 3x3 matrix, right? This also determines the size of the receptive field. So the filter is then applied to an area of the image, and then we complete a dot product, as I have shown, and then this dot product is then fed to an output array. Afterwards, the filter shifts by a stride, repeating the process until the cake, is swept across the entire image. So as I was showing you in the Excel part, on how we move using the stride, right? And then the number of filters affect the depth of the input. Let's say if we have an input 24 by 24 by 3, we then pass it into a receptor, into a filter, which is 3x3, right? We get an output with a depth of 3, right? If we pass it by using let's say we use an image with 224 by 224 with a depth of 3, we pass it by on a 12 by 12 filter. We then get a depth of 12, right? So this is how the convolution works. So in the next video, we'll be talking about padding and max pooling. Thanks for watching, guys.